right, so to use the law of sines, so we're just summarizing here. To use the law of sines, must you have a what and its what? An angle and its opposite side. There were two cases that we worked with last time. Angle, side, angle, and angle, angle, side. Both of those will always produce one triangle. Today we're working with the second type of case, and that's your SSA or ASS, if you want to write that word on your paper. If you don't, whatever. This one will make 0, 1, or 2 triangles. As we work through them, I will tell you how many there are so you can kind of adjust your handwriting, because if there's 2 triangles, you're doing double the amount of work. You'll have 2 full charts. And then and obviously when you're doing your worksheet, you won't know which ones have 2. So I will explain how you figure it out. I won't just be like, hey, you've got 2 on this. You guys have to know how to figure out 2. So don't be the kid on the test. Don't be one of these who gets 1 triangle and then moves on, because if there's a completely second triangle, you're going to miss 6 points.
Nice.
Yeah, because you'll have another full chart. All right, so recall from geometry that you can prove 2 triangles congruent by angle, side, angle, and angle, angle, side, but you could not prove it using ASS. And most of your teachers would just say, hey, it's a bad word, can't use it. But the reason why is because it really can produce no triangles whatsoever, just 1 triangle or 2 triangles. And that's because if you have ASS given to you in a triangle, if you have an angle, side, you've got an angle and its opposite side, so you can use the law of sines. But what would you be solving for if they give you another side? So if they give you an angle and 2 sides, you would be solving for the what? You'd be solving for the missing angle. Well, how do you solve for an angle in trig? You have to use an inverse, and our calculator can only search for inverses in certain quadrants. So because we're using the law of sines, you'll be using an inverse sine. An inverse sine. So in the first quadrant, remember that your inverse sines of positive ratios are searched in quadrant 1, and they return to you what type of an angle. They give you an angle between 0 and 90. And how would you classify an angle between 0 and 90?
Positive.
It is positive. Between 0 and 90 is what type of an angle? Acute. It's an acute triangle. And that acute triangle will represent the reference angle theta prime. Remember back from a couple chapters ago, theta prime, the reference angle always between 0 and 90. So your calculator can only return you an acute angle. So it misses the possibility of the other y value, because this is saying what angle has a y value that's positive. Well, what other quadrants have y values that are positive? Quadrant 2. So your calculator misses this one. It cannot return to you what type of an angle. What type of an angle is that in quadrant? Obtuse. It can't give you an obtuse angle. So we have to use our prior knowledge of reference angles. Remember, reference angles are from the terminal ray to the closest x-axis. So you would have another reference angle here. And the reference angle and that obtuse angle would total what? They would total 180. So we'll use the idea of reference angles to help us figure out if there is a second triangle, and we'll go all through that when we get there. But this is why in geometry ASS was a no-no, because the ASS that was given could give you an acute angle or an obtuse one, and that produces 2 different triangles, so it wouldn't necessarily make a congruent one. So that's why it was the no. So we're still going to be using the law of sines. To use the law of sines, you have to have an angle and its opposite side. Let's rock and roll. All right. There we go. Number 1, I will tell you that this one does have 2 triangles. Okay, so adjust your font size to fit enough work to make 2 triangles. So we're going to pretend that we didn't know that there's 2 triangles. Yes.
What font size do I need?
Like, you have pretty good font size. Your
What about
font
my
size should be
font
good.
size?
No,
Like,
you need to
you size
reduce.
Is Times New Roman 11 or 12?
Like 9 or 10.
Really?
Yeah,
Single.
single spaced. All right. Here we go. Triangle. A, B, C, 40 degrees. Little a of 4 across from the 40. Little c of 5 across from the big C. So we're missing beta, gamma, and little b. From the triangle, you can see that you have an angle followed by 2 sides. So it makes an SSA triangle, which is either 0, 1, or 2. We'll fill in our chart. 40, 4, and 5. And then leave yourself room under here to put a second chart. Because I've told you there is a second triangle, so you will have a second chart. But we've got to figure out how we get to that. All right, so to use the law of sines, you have to have a what and its what? An angle and its opposite side, which we do. We have 40 degrees in the opposite side of 4. So we're going to start off with our proportion being the sine of 40 over 4 is equal to, what angle do they force you to solve for? Gamma, because we have little c is 5. So we'll have the sine of gamma, or you could put big C there, over 5. We cross multiply, keeping in mind that your unknown is that angle. When I cross multiply, I like my unknown to end up on the left side, so I always cross multiply and put it on the left. So I'm going to put 4 times the sine of gamma on the left side, but it really doesn't matter. It's just so my variable ends up over there. Equals 5 times the sine of 40. So you have 4 times the sine of gamma. You have to get rid of the 4 with division. So we'll have the sine of gamma equals 5 times the sine of 40 over 4. And then you're solving for gamma, which is an angle. So to solve for an angle in trig, you must use an inverse. So we'll have gamma equals the inverse sine of 5 times the sine of 40 over 4. And we're going to type this in the calculator, and we will store it to C because we found gamma. So we'll do second sine to get the inverse, and then in the numerator we need 5 sine of 40 divided by 4, not 7. There we go. 53.464 is what you should get, and store that value to C. I already forgot, 0.464. And then put that in your chart. All right, the next thing we can find is what?
Yeah.
What can we find?
We can find
the missing angle. The 3 angles have to total 180. So we'll have beta equals 180 minus the 40 that was originally given minus the gamma that we just stored. So 180 minus the original 40 minus alpha C. And then store that value to be 86.536. Put that in your chart. And then you still have one thing left to solve for this triangle, which is the side little b. So we go back to the law of sines, and I would just use the one that we originally worked with, the sine of 40 over 4. Equals, and then since we're solving for little b, we have to use beta. So we'll have the sine of beta over little b. And so my brain, this is just something I do, you guys don't have to do this, so my brain knows the variable that I'm solving for. I'll circle little b. So I know that's what I want to isolate. So I cross multiply little b times the sine of 40 equals, oh dang it, there's too much, little b times the sine of 40 equals 4 times the sine of beta. Divide, so we get little b equals 4 times the sine of beta, which is already stored in your calculator, divided by the sine of 40. We get 6.212. You don't need to store that value, but put it in your chart. And then double check your chart. You've got the biggest angle is 86. It should be across from the longest side. And then your smallest angle is 40, and it should be across from the smallest side. So remember, we're working with angle side side or side side angle. It makes 0, 1, or 2 triangles. This one clearly made at least 1. So 0 is ruled out. We have to check to see if there's 2. And there is. So I'm going to go ahead and have you guys make a second chart. When we make the second chart, you need to differentiate it from the original chart. So I like to put prime so I know it was my second triangle. So I'll have big A prime, big B prime, big C prime. Everything gets a prime. So you know that it belongs to
You just box it.
the second, to what?
Like put it in a box.
Put it in a box. I mean, whatever. We're going to be using A, B, and C again. So I just want you to know that it's different. All right. So if the triangles make a second triangle, the 3 original pieces of information will still apply to the second triangle. So the original 40 degrees, the 5 for the C, and 4 for the A. So all of the original information is still given. So to check for the second triangle, to check for second triangle, you will use the angle you inversed as a reference angle. I don't know why that box is up there hanging out. So the angle that we inversed was which angle? So we found it,
C.
we found C, we found gamma. I don't want you to put, you will always do it with gamma, because depending on the information that they give you, it could be alpha, it could be beta, it could be gamma. In this case, it's gamma. So we will take, we will be finding, hang on, what color did I use? Purple. So we're going to be using gamma to help us find gamma prime. And remember that gamma that we found is an acute angle. It's 53.464. Your calculator searched in quadrant 1. It did not find the quadrant 2 angle. It didn't find the obtuse angle. So we're going to use the idea of the obtuse angle and the reference angle forming 180 degrees. So we're going to take 180 minus the original gamma. and that will give us gamma prime. So 180 minus alpha C gives us an obtuse angle. We are going to store this because this becomes new gamma. So you need to store this over the old one. So you just hit store alpha C. So 126.536. And then put that in your second chart. That was step 4. All right, so at this point in time, we still don't know if we have 2 triangles or not. You will always do this after you get one triangle with ASS. You will take 180 minus the angle that you inversed, and you will get its new obtuse angle. Then when you put it in the chart, this is how you'll know if you have a third triangle or not. The 3 angles of any triangle have to total what? 180, have to total 180. So if the 2 angles in your chart, the one that you just found by subtracting from 180 and the original one that's given, if they total to be less than 180, you have room for a third angle. If the 2 angles in the chart are already over 180, then you don't have room for a third angle, and then you can't have a second triangle. So what's 126 plus 40? 166. So do you have room left over to have a third angle? Yes. So then if you have room left over to have a third angle, that means you have a second triangle. So we need to find the third angle, which is beta prime. So step 5 will be beta prime is equal to 180 because all 3 angles total 180 minus the 40 that was originally given minus gamma prime, the new gamma that you just stored as the 126. So we'll have 180 because the 3 angles total 180 minus the 40 that was originally given minus the new gamma that you just stored. And we get beta to be a little acute angle of 13.464. And you have to store this because that angle will then be used to find what? What's left in the chart? The missing side for little b. So store that to beta, so that's your new b. And 13.464 goes here and in the chart. And then we go back to the law of sines. We use that original proportion or original ratio, sine of 40 over 4 equal to the sine of beta prime over little b prime. And little b prime is what we're trying to find. Cross multiply. B prime times the sine of 40 equals 4 times the sine of beta prime. Divide it over. So 4 times the sine of beta prime over the sine of 40 will give you your new little b. If you don't save the new b for this spot, your answer will come out to be the same little b as the first one. All of your values should be different. So if you get the same little b as the last triangle, that means you didn't really store your new beta. So 4 sine of new beta divided by the sine of 40 gives us 1.449. So if you are able to complete a second chart, then that means you had how many triangles? 2 triangles. Whew. The only type of triangle that can even make 2 triangles is ASS. You don't check for two triangles with ASA. You don't check for two triangles with AAS. Only ASS. Don't make one of them out of you. Always check for two. And the check, after you complete your first chart, it's always the reference angle idea of 180 minus the angle you got from the inverse. So it comes back to step one. Okay. All right. Second problem. Number 2, you don't need near as much room. Let's draw our triangle. And get your chart set up. And you'll notice in the triangle, you've got an angle in two sides. So this is an SSA, which can make 0, 1, or 2. To use the law of sines, you have to have the sine of an angle over its opposite side. So you need an angle in its opposite side, which we have, the 40 and the 2. So we'll start off with the sine of 40 over 2 equals the sine of, what angle are you forced to solve for on this one? Last one we solved for C. Why? Why do we solve for gamma first on the last one? Because they gave you little c. This one gives you little b, so you have to solve for beta. So we're going to cross multiply. 2 times the sine of beta equals 5 times the sine of 40. Divide by 2. You're solving for an angle, so you have to use the inverse. And probably by now, some of you have typed it in once, and probably some of you even typed it in twice. Why did some of you type it in twice? Because it gave you an error, right? So you're like, ooh, maybe my prom nails hit the wrong key or something like that. So you type it in again just to make sure that you didn't mistype it, but you didn't mistype. You have to think about what this means. So we're going to go back to what we typed in. And we are going to take a look at the ratio. We're going to look at the ratio. Look at the ratio. So just type the ratio in the calculator. Don't do the inverse sign. So I just want you to type in 5 sine of 40. Divided by 2, because sometimes our prom nails do get in the way and we do mistype things. So I would definitely, if you get an error on your calculator, type it in again and make sure that you didn't just mistype something. If you get an error again, go back and inspect the ratio. So when we type in that ratio, we get 1.607. So we're looking at beta is equal to the inverse sine of 1.607. And we think about what this really means. We don't want to just type stuff in because Ms. Barrett tells us that's what we should do. We have to think about what we're typing in. What does this mean in trig? Anytime you're inversing, you're solving for an angle. So you're asking yourself, what angle, right? What angle has a y value? Where do we get y? Sine. What angle has a y value of 1.607? So what is that in reference to? What angle where? What angle on the unit circle has a y value of 1.607.
No,
What? Why is it called the unit circle?
it's 1 unit.
It's 1 unit as a radius. So the furthest out it can go at any point in time is what?
1.
1. And 1.607
0 times.
is bigger than 1. Bingo. So this can't make a triangle whatsoever. So you take a look at the ratio, and if the ratio is greater than 1, then you have 0 triangles. So your conclusion is 0 triangles. So I definitely, if I was typing this in, especially on the test, because that would really stink if our prom nails hit the wrong key and we wrote 0 triangles, but it was 2, because then you'd be like minus 12. So always double check the error and see if you mistyped something. If the ratio is bigger than 1, it can't work. But if your ratio is between 0 and 1, then it should have worked and you probably did mistype something. All right, to the back. For font size reference, bless you, this one will only have 1 triangle. Okay, so you don't need to worry about condensing so much.
Do size 14.
Do what?
Size 14.
Size 14 is just fine. Brent's normal font size is fine. All right, I'm going to go ahead and I'm going to draw an obtuse angle because it gave me A as 110. But you don't have to. You can just do your,
You can have an option triangle on your screen.
on my screen thingy.
No.
Oh,
Where'd you get
I can
that
draw
from?
oh, on my skirt. Oh, it's a dress. LuLaRoe. I was like, oh my God, that's a math dress. I have to have that. Because I'm a nerd. 7, 5, theta, B, gamma. You don't have to draw an obtuse triangle if you don't want one. You can just draw like a generic one. But you do need to recognize that this, once again, is angle side side. And angle side side can make 0, 1, or 2. So to use the law of sines, you have to have an angle in its opposite side, which we have. So we're going to start off with that first ratio of our proportion as the sine of 110 over 7 equal to the sine of what angle do you have to find? It forces you to find C. Gamma over 5. Go ahead and work on your cross multiplying, dividing, and inversing, and store C to your calculator. Make sure you store it. You should have gotten 42.160. And then place it in your chart. And then to get the third angle of the triangle, that's step 2. Was 180 minus 110 minus our gamma. And make sure that you store that value to B. So 27.840 is your rounded value. And then you find the missing side, you go back to the law of sines. With that original half of your proportion, the sine of 110 over 7 equals the sine of the beta value you stored over little b. .479, and you don't need to store that because that was the last part of that triangle. Go ahead and make a second chart. Remember that all of your original values that were given in the problem apply to the second chart. So we have that 110, opposite side of 7, and a length of 5. So to check for a second, I'm trying to get this done because I got 2 baseball boys that are leaving. To check for a second triangle, it's going to be gamma prime, because that's the angle we found first. We were forced to solve for it, and it's the idea of a reference angle. So you have to do 180 minus gamma. Type that in your calculator. No, 180 minus gamma. And that gives you, that's your new gamma is 137.840. And you put that in your chart, 137.840. Now you check for the second triangle. The only way for there to be a second triangle is if there's room for your third angle. Look at your first one and look at your second one.
No,
Why?
too big.
Too big. It's already over 180. So there's only one triangle. Lunch. Ooh, don't trip.